All right, ladies and gentlemen, hello and welcome back once again to the longest running show in the world about data. It's called DM Radio. Yours truly, Eric Kavanagh here. And folks, I'm super excited to have a new guest on the show and an old friend on the show as well, talking about the hottest topic in the business world these days, large language models. We're going to be talking to David Sweenor. He is the author of Tiny Tech Guides. Look them up. He actually wrote a book about language models with our buddy Eve Mulkers, who couldn't make it today, but he'll be back, I'm sure, in a future show. And Daniel Bukowski is the CTO of a company called data². He actually is a new sponsor for our show. We're very happy to have him on board. And they'll be doing a show with Neo4j in early April on a similar topic, all about graph rag. So we'll bring those gentlemen in just a couple of minutes. And first, I wanted to share with you all this sort of epiphany I had last night thinking about this show and the topic and these large language models. And I'm very curious to hear what our guests think about this. But I was thinking about how, in the world of computing, if you go all the way back to the beginning and figure out where we've gone, what we've done, what an information architecture really looks like, and really the database has always been the foundation. A database has always been the core of whatever we've done. And on top of the database, you layer all sorts of applications that do what? They talk to the database to get information, CRUD, right? Create whatever it is, update, delete. Um, so the database and the applications are two major components of every architecture. You also have a network to get to stuff. You have a file system to find files in there. And the files can be the apps or the databases, the execution files, if you will, and then other files that support it. But the files are either the apps or the data that are used by the apps. Well, in that whole time period, which is like 50 plus years, everything we've tried to do to improve these environments is focused on performance, scalability, speed, really more than anything, data quality, things of this nature. And what I find remarkable is that all of a sudden, with these large language models, we're throwing a lot of the work we've done out the window, at least if you don't use these things properly. Because again, we've been focused on improving the speed at which we get the information that we stored to use it in an application to do something. Well, it goes without saying or should that whatever we store in a database is what we want to get back exactly as we store it. Strings of text, numeric values, whatever it is, we want to get it back as it was persisted in the database. That's data quality, data integrity, basically. Well, what do you get with large language models? First of all, this is the first time that I think that we're seeing something other than a database play a central role in what we're doing. So if you're using ChatGPT or Gemini or Claude or any of these guys, you're not really using a database. I mean, there may be databases in the workflow, but these deep learning modules, they're not traditional databases. And the aha moment came for me a while ago, probably like 6, 10 months ago, when I was talking with someone on the show, when it really struck me that when you train a model, you're not persisting strings of text or values like we have in the past, which will then be collected. Because think about it, all this work we've done has been focused on improving the efficiency of getting information into the database, getting information out of the database. So that's everything. That's what we worked on. Concurrency, concurrent users, right? That's a big thing. I want 1,000 analysts hitting this database at the same time. Well, you got to really engineer to make that happen. But all of a sudden, you get these large language models that are deep learning modules. They do not persist text in the usual way. What they do is they store weights and biases in the parameters. And there are billions in many of these large language models, there are billions of parameters. So that's when I was like, wow, well, no wonder they hallucinate. Now, they don't hallucinate. They're not taking magic mushrooms or anything. They just really confabulate or conflate. And all they're really doing is reflecting back patterns of words based upon the patterns they've been trained on, which have been persisted in the weights and biases of the parameters. So my point is like, how interesting is it that we spent all this time, 50 years, really optimizing database technology, network technology, file systems, and applications to be able to do cool stuff, and all of a sudden this huge curveball goes flying toward the entire stack and sends it all cattywampus. Well, I asked the question in the abstract, what part of your business can be wrong 20% of the time? And the answer is almost nothing. Like, there's not a lot of your business that could be wrong 1 in 5 times. And that is the standard level of accuracy for these large language models. So it's like, well, it's not very accurate. So what do? You have RAG models, Retrieval Augmented Generation, and there are countless ways you can do that. There are all sorts of things you can do, but basically you're using a vector database, which is similar in what it does to how the deep learning modules operate, in that you convert text into numeric values, weights and biases. They're vectors basically, so a point and then array in a certain direction, pointing in a certain direction. And the key to remember with these LLMs is that they're really consensus engines. That's what they actually are, is they've been trained on lots of patterns of text, and then based upon your prompt, they will reflect back a pattern of text that is similar, and it's the average of what they've seen. Like, this is very important. So it's a consensus engine that's giving you the average of what's been published about a particular topic that it's been trained on. All right, that's pretty cool stuff. But even with the best RAG models, you're like talking 90% accuracy. In fact, I saw Andrew Ng, NG, last name is spelled, one of the real pioneers in this space, and he had a couple young kids with him, and they were bragging about how they got accuracy up to 90%. And I'm like, well, that's great, but what part of your business can be wrong 10% of the time? Like fulfillment, accounting, sales, marketing? Maybe marketing, because marketing is kind of loosey goosey. So it is great for text. But the answer is, it just can't. No, you can't do it that way. So what's the other answer? And I've done a lot of research in this space. Graph RAG, I would argue, is a crucial component. And we're going to hear from Daniel Bukowski in just a second. Graph RAG, I think, is the answer for getting that last mile, which is a very, very, very important mile. And of course, graph has been around for a long, long time as a computational construct for, I don't know, 35, 40 years maybe, probably longer. And as a concept, it's been around for centuries. If you go look up the history of graph theory, it's quite fascinating. There's a guy, I can't remember his name, but it's all about the bridges in some European city, and he was trying to figure out how to cross all the bridges. And so he came up with graph theory, which is fascinating stuff. But it's all about relationships. So nodes and edges, the nodes are entities, the relationships are characteristics that the nodes can share. So it's great for understanding networks. It's great for understanding relationships between objects, between things. So you can kind of do the math in your head and figure out, wow, yeah, so graph RAG as the intermediary between the prompt and the large language model can be really very powerful in minimizing those errors and really getting it to focus on the content that you need from your systems. And I think that's a really, really big deal. I think it's crazy. But anyway, with all that, let me bring in Daniel Bukowski of Data Squared. What do you think about my assessment and kind of where are we today with Graph RAG?
I love it, and I would not be a good, former Neo4j employee if I didn't know Leonard Euler and the Seven Bridges of Königsberg,
There
which,
you
as you
go.
said, is exactly where graph theory came from.
Right.
But no, absolute pleasure to be here, and there's a lot of interesting things we've learned from language models. As you gave a great overview, and I think there's a lot of technologies and approaches that are going to stay the same or maybe change just a little bit. But then, as you said, as we get to that accuracy and kind of what you need for a production deployment, there's still a lot of work to do. And I think that's where graphs are going to play a key part in this. And just as I was looking at the abstract for the show and talking, hearing your introduction, I really think this is just like any other software or data science or machine learning project where it still has to start at the foundation of solving a real business problem. So I think as we, whether you're implementing vector-only RAG or graph RAG or whatever use case, whether how high or low it is kind of on the value chain, it still has to start with a solid business problem.
Right.
And so any one of my old bosses was explaining that if you don't have a real business problem with what you're working on, it's just a science experiment, and it might last 3 months or 6 months, but it's not going to go anywhere from beyond that. And so, as we get into these advanced deployments, and you really talked about the importance of software engineering and architecture and data quality and data engineering, all of those domains are critically important and are what are going to come together in an application or a platform to make sure that you're solving that business problem at a level of accuracy that's acceptable. If you think about some of the research, I think I saw this coming out of McKinsey, where the top use cases for LLM right now, or one of the top use cases, is kind of high-level customer service, routing someone to the right agent or to the right agent, as in a person or an assistant, routing someone to the right source of information to support a product or figure out something going on with your credit card. those are really popular use cases right now because you can probably be wrong 10 to 20% of the time. You're just sending someone to the wrong person. They're going to get rerouted, and it's not a critical business application where lives are at stake or trillions of dollars are at stake. I think if we look at the accuracy issue and the existing kind of architecture that's relying on the LLMs out of the box or a vector only approach, that's why that use case has really taken off because it is one where you have, some wiggle room when it comes to inaccuracies. But at Data Squared, what we're building is an application or a platform that uses LLMs and uses graphs and graph RAG for those high quality use cases where you can't have, it is not acceptable to have 10 to 20% failure. National security, energy, critical infrastructure, cybersecurity, those types of use cases where you really do need that extra architecture, those extra guardrails to make sure you're getting the accuracy and transparency that you need for, a high
Right.
level, kind of really high up on the value chain as far as business applications or system applications. So that's kind of how we're thinking about it, and it makes sense when you take a look at what is really the leading production applications now and what's the level of error that's acceptable versus where business critical applications need to be before AI is deployed into meaningful production.
Right. Absolutely. And that level is very, very high. And like you suggest, some of these customer service examples can survive because they can automate some simple process. But I was at the current conference in Austin, I guess 4 or 5 months ago, and the Kafka company, of course, and they had their top researcher who said, "Look, I'm going to be honest with you. All the use cases we've seen that are successfully in production are inward focused." So they are not customer facing. They're like a co-pilot. And as a co-pilot, it's very, very powerful. It's great because you are the human in the loop still, and you can take decisions or not take decisions based upon what you see. But the key, as you suggest, and I know that at Data Squared, you folks are working on some really mission critical use cases where that accuracy has to be like 98, 99%. So if you would tell us a bit about how you do that. I mean, I can understand conceptually how you can put a graph into the workflow to kind of grab some context to understand sort of the boundaries or the relationships that matter in this prompt that I'm pushing up to the LLM. But can you kind of talk about how that actually executes and why it's able to jack up that accuracy?
Absolutely. And it comes from the thesis that really has been proven out, not just by Neo4j, but also by Google and Microsoft and BlackRock and others in academic literature. It's proven out that the LLMs like it when you tell them how the data is connected, how the data goes together. The analogy that I like best is think if I have, a 500-piece puzzle, and we're going to work on it. The way vector-only approach operates is if you think about every piece of data as a piece of the puzzle, what you're doing is taking that box and just dumping it out in front of the LLM and saying, okay, put it together and figure it out.
Right.
The LLM can do that, but you and your organization know your data much better than the LLM does out of the box, even if you fine tune it, even, whatever, foundational model you're using. You know your data better than the language model. And so what a graph does is it puts the pieces together. So if you think if I put all the pieces together, or even just, if you just do the box, kind of the outer ring, how most people start, if I put that together and then show it to the LLM and say, explain what's in this information, explain what's in this puzzle to me, it's no surprise it can do much better than if it has to put all the pieces together and then explain what's in it, because it might not put those pieces together properly. Even the new
Interesting.
thinking LLMs, they're really, really good, but they still struggle to get that 80, 90, upper 90% accuracy. So why wouldn't you put the pieces of your data together
Right.
or you provide it to the LLM if you're going to get that much better of an explainable, transparent, and accurate response? And so our platform, it's called Review, brings together all the pieces, Neo4j, the foundational, graph database. We use a vector database, and then we have basically an API-based infrastructure where we help you get your data and get your critical data into the graph, interact with that data, because even just interacting with your data can add a lot of value. I
Yeah.
started as an intelligence analyst, almost 20 years ago, building link charts by hand to do follow the money investigations. I used to be an accountant. So I would connect the dots and where money was flowing and who's sending money here and what's happening. And so when the Panama Papers hit, that was my eye-opening experience to go back to grad school for data science and kind of move into technology.
No kidding.
Published using Neo4j. So we get your data into the graph. We give you the interfaces, whether you want to click and see the graph and interact with the graph, or even just see it as spreadsheets or kind of like a tabular format, which a lot of people are still used to. We want to give you all the different ways to operate with your data, even though there is a graph underneath, kind of in the back. But then where the LLM and AI come in is in that reasoner, where you can have that natural language interaction with the graph using a language model, using GraphRag, and also using vectors, because vector stores definitely have their purpose. We want to bring
Right.
all the tools together, to give you the best response possible. So that's where we bring portions of the graph as, based upon the question, we will query the graph, bring back the appropriate, the nodes and the relationships, how they're connected, bring all of that together, provide that to the language model with some prompting, and we have all kinds of patents around our approach to this. But it's basically bringing all of that together and giving you the most accurate, transparent result possible. So when you get a response in our platform, every sentence, every fact is going to be cited back to the graph, whether it's a node, a relationship, a property.
Oh,
So you
wow.
know that every piece of
Right.
information is coming from your domain, your knowledge. And so you can rely on that information and even check if even have built-in checks to see if there might be a hallucination, because you
Wow.
can't fully eliminate them, but you can put a lot of guardrails and minimize them and even identify where they might potentially exist and either retry that portion of the question or at least
Right.
make it available to the end user to, okay, I change happy to glad here and we're good to go.
That's really interesting, and I love that you're doing the citation to the graph
Yeah.
because you notice, like when these things first came out, they weren't doing citations, and it was all off the rails. They're like, "All right, guys, we got to put some citations in there," and so they started doing that. But to cite the graph is fascinating because then someone can jump in and see, all right, where does this fit in our world? Well, don't touch that dial, folks. We'll be right back. You're listening to DM Radio. All right, folks, back here on DM Radio, already having a blast here talking about lessons learned with large language models. And my good buddy Eve Mulkers was supposed to be here, but he got tied up today over in Belgium. He's a good distance away from us, but he's been doing a lot of work in LLMs, and I'll talk about some of his findings later on the show. But first, let's bring in David Sweenor, author of Tiny Tech Guides and all around enterprise software aficionado. David, you heard us talking about my theory of what's happening, and then Daniel gave some really good gritty details of what they're doing. What are your thoughts on where we are right now with LLMs and GraphRag?
Yeah, Eric, thanks for having me on. And I agree with everything that's been said. I might push back a little bit on the database piece. I think the new database is the world's data that is embedded in the LLM.
Hmm.
So, like it or not, it's there, and we got to know how to keep the bad stuff in there and get the good stuff out that
Right.
we want. But having these enterprise systems, I think there's two things that people should consider. One, everything that Daniel's team is doing, you're going to need that to get the maximum level of accuracy that you can. But we have to also look at the people dimension. Humans are always going to be in the loops. We have enterprise systems that are going to feed people. Now, these people, they're also using LLMs, whatever service they want. And I don't think a lot of people, I mean, we all know they lie. We all know they make up stuff. I had SH star star here in my notes, but they make up stuff. And like they'll give you a beautiful citation. But if you go look for that citation,
Right.
it doesn't exist.
Right.
Um,
Like some
they
term papers, I'm sure.
they can't do math at all. So you have to have some sort of multimodal system, shelling out to a Python script or some sort of calculator engine. So we gotta think about that for our systems. And a recent one for me, I was trying to use an LLM to help me with my social media planning. It turns out they can't schedule either. They have no concept of the calendar and what days and dates correspond. And that was a new one to me. So I think when we think about an enterprise system, we got to figure out how does the human and the machines and plus machines interact together, because there's a lot of people will just blindly take the output, and you opened, Eric, with
Right.
you'll be average. And if you want to average response, that's great. And so I think people that are using it on sort of individual level, they need to set up their personal chat GPT or whatever system they want to sound like them, to have knowledge about how they speak, and it can access that. You can turn memory settings on or off. I did a whole post on this, but I think these things working in a concert, and I don't think we've tackled that. And then one more thing, I guess, on the sort of the hallucinations or confabulations, whatever word we want to use. I don't think anybody has cracked the nut on how to test and monitor this at scale. And what I mean by this, with predictive analytics, it's pretty straightforward. We have numbers, we can watch distributions, and we can see if they shift, data drifts, or what have you. But when we're dealing with text, we're dealing with audio, we're dealing with video, we're dealing with images. I don't know what the state of the art is, but I don't think anybody has cracked the nut on how to monitor that at scale. I have a theory on how we could potentially do it. And some people say, hey, we're going to use LLMs to monitor this, and sure, we're going to do that. But I think you might have to take like a manufacturing approach. You can't inspect every widget you make. So what do? You sample. I'm going to inspect a subset of the widgets I make. I'm going to go test them. And I think that's what we're going to probably end up, having sort of a manufacturing mentality to these systems when you're generating unstructured content at scale. Because how do you monitor it? I think it's almost nearly impossible.
Yeah, well, that's a good question. I'll throw another thought at you, David, and see what you think about this. The other way to describe what we've done here is it's almost like uh, installing a noise filter in the content. So if anyone's ever used Adobe Photoshop, there's something called a noise filter where you can add noise to an image, and you do it to make it look grayed out, or for some
Mhm.
artistic effect, basically. But what we've done is added noise to signal. And so it's kind of like, on a radio station, if you don't get the dial just right, you get static, basically
Sure.
white noise, and you have to get it just right to get that nice clear signal. And boy, what a difference a tiny twist makes on your radio. It's especially annoying when you're driving out of distance. If you're like going across country and your favorite song's on, it starts to clip out, and some other
Mhm.
horrible song is clipping in. You're like, oh man, I'm trying to make time here. I don't want to turn around and listen to my song. If you don't have a CD player, I guess you have to deal with it. But or an iPad or whatever it is, iPod used these days. But my point is that we're inserting noise into the content and the output, which is kind of odd. And of course, we're only doing that because of the nature of how these models work, and it's sort of a side effect, if you will. And with all these models and graph rag models, for example, we're trying to fine tune, and that's a very specific term too, right? You can fine
Mhm.
tune models, in which case you're just adding layers for the model to process. And I'm guessing that's probably a bit more sophisticated than using a RAG model, but it still can be done. But what do you think about that? The fact that we're like just frankly inserting 20% noise level with any generic LLM. What do you think?
Yeah, I think that's an interesting perspective. And I think, you have to filter out the bad, and we want to get out the good, and we want to insert, our stuff that our organizational context. I think we have to be careful though, because we've seen with social media, let's imagine a world where everybody has their own personal AI bot, whatever term we want to use for this. And it is particular to what you like. Well, we've seen the impact of what this is like for social media. It's really devastating, kids' lives on TikTok and things like that. So if it feeds you constantly whatever you want to see, how
Right.
do you get out of the echo chamber? I
Right.
think we have to be, we've already seen this. It's been, very, very bad things have happened in the world. So I think we have to be very careful of how personalized we make these things.
Hmm.
Um,
Well,
the, oth- yeah,
that's
go
the
ahead.
other side of the equation. So I'm going to give you. I mean, we're trying to talk about lessons learned, and you're hinting at one right here. But I just want to throw out an architectural idea for you, where I think these can be very, very powerful. Is you think about customer service. Someone calls into a call center. Well, USAA was the first company I came across that figured out how to do like phone number like recognition and bring up my record. Like, hello, pretty important stuff. Like it's calling in and like, okay, that number. Oh, okay, we found a
Mhm.
record. So they got a real time system that's matching the caller ID with their system. Okay, it looks like Eric's calling in. So that starts the process of bringing up the record. Well, now with Gen AI, if you have a prompt in there somewhere, that can bang go grab a whole bunch, especially if there's a graph model that they have in their organization. You could hit the graph, hit the vector database that is populated with information about my record, and boom, all of a sudden you can have really interesting ideas being shared with the customer service rep. Say, hey, he was in the store yesterday, he was very unhappy, or whatever. But it can pull stuff. That is a use case for Gen AI and for large language models. What do you think, David?
I love that. And it goes back to Nirvana, where when we were even working in the database world, we could get all the data in a shape and format that everybody could access. We're here now. And we're saying the large language model can do it, but you still have this problem. The data is all over the organization. It's a mess. Nobody knows where it is and what's in it. And so I think we still have to overcome that problem of how to get it in the right shape and format so it can be ingested by do we call it GRAG, Daniel? I don't know, but the graph RAG
The
system,
Greg,
the GRAG, it's like the Kraken. But we we
like
we have to
Graggle
find a
Rock.
way to get this all in a accessible location. And I think we're still gonna to struggle with that organizationally.
Yeah, I think so too. Well, Daniel, I'll bring you back in. First of all, I saw you nod your head in the affirmative on that use case. And just in general, and again, you have to be careful what you point these things at, right? So, one of my mantras these days to organizations everywhere is get your data house in order. Pay close attention. There are some tools and technologies to do that now. Um, there's a company called Shelf IO that's doing some interesting work there. There's a company that we've worked with. I have to look up the name. It's terrible. I can't remember right now. A couple of companies we've worked with, they're in that space. But if you get your house in order and then start training your vector database or your graph on your enterprise data, that's how you can unlock this whole array of use cases, right, Daniel?
Absolutely. And to the point, the point that was made earlier around these large language models, in a way, are databases. They've been trained on the internet and now increasingly synthetic data. That's a lot of data, but there's a lot of good data, but there's a fair amount of not so great data. So that gives them the foundational capability to predict the next word, predict the next token. And as you mentioned, Eric, it's going to be kind of the statistical average or the consensus of what the next token should be. We know that there's going to be a lot of inaccuracy built into that. So if we turn it inside a large organization, you mentioned USAA, how many versions of Eric Kavanagh are inside USAA? Is it there's banking, there's credit card, there's home insurance, there's auto insurance, there's financial planning. And I've seen, when I was at Neo4j, worked with some large banks where they might have 10 versions of the same person, depending on how big it is, how many products and services they have. So which Eric Kavanagh do we care about for this question? And how do you know which one? How do you actually get a full, complete picture of any single piece of data? And so, when you're saying with RAG, you provide your internal data to the language model to help answer the question. It's a lot of work to make sure the data that you're providing it is accurate and complete and tells the whole picture. And that is actually a common graph use case. It's entity resolution. It's
Right.
hey, I have these 10 instances of this person, this customer. Maybe I just have one that is kind of the central, and then it points to all the other instances, acknowledging that it's the same person. This is Eric. Okay, this is Eric's credit card. This is Eric's mortgage. This is Eric's auto loan and auto insurance, all connecting back to the same person. You provide that to the language model. That is very efficient, very complete, very traceable information that will get you from 60 to 80% to that 100% with the meaningful context that you need. And then it kind of comes full circle. How do you identify hallucinations and how accurate it actually is? I completely agree. I think there's going to be an element of statistical sampling, but another way you can approach it even on the front end is do I have good, real citations inside my own data to
Right.
every piece of this information?
Right.
If not, that's a risk of a hallucination. And so you
Interesting.
mentioned the LLMs citing papers. It's one thing to just cite, hey, I referenced this paper. It's another thing to say, I referenced this paragraph on this page, this specific sentence. So I don't have to go comb through 30 pages of academic literature to find the one important piece of information. And that is something that graphs can really provide you, that much more finely or much more granular citations down to specific elements.
Yeah, that's an excellent point. And I'm thinking to myself in terms of how these things operate and what they do. Again, it's a consensus engine. So for anything that has been widely published about, it's going to do pretty well. It's the fringe topics where it gets kind of cattywampus and just makes something up because it doesn't know what to do. It doesn't have enough of a frame of reference to understand. So that's where you get into your enterprise data. And I always tell people be very careful about where you point these things. If you start basically populating your vector database with whatever is in your databases somewhere, there's going to be some junk in there and there's going to be some stuff, and that's going to cause not even a hallucination, just a reflection of bad data, right, Daniel?
No, I saw that exactly with the customers I was working with. I was heavily involved in a lot of Neo4j's original graph RAG and kind of graph AI integration work. And if we go back to 2023, every developer or data scientist I worked with had a cool chat with your PDF project. You could download LangChain, point it at a PDF, get some answers, do that on a Friday afternoon. That was cool. Like that was, hey, we all did that back in 2023. As the calendar turned into 2024, my customers started getting, okay, here's a directory of who knows what. It is
Mhm.
text files, PowerPoints, formats that we haven't used in 10 years. Now I want you to do the same thing with that data. And that's where kind of everything old is new again. You
Mm,
needed really good data engineering skills, really high quality data, because some of the initial, efforts, like if you take all these different multimodal pieces of information, PDFs, PowerPoint, but then you throw in some spreadsheets, which don't really vectorize very well because it's structured data. Now what do you do? And that's where, chat with PDF was 2023. Now it's give me accurate cited information across a several thousand file directory. And that
right.
was again where graphs came into this, where we could integrate the structured and unstructured data to the level of the best example I had was a company needed to understand policies and they needed to know the difference between policies in California and in Florida. And that is
Mm.
very, very specific. Oh, it might only be a few words. Traditional vector RAG just didn't have the accuracy for it.
Very interesting. That makes a lot of sense, and you're bringing up an excellent use case which requires specificity. One word wrong can throw the whole thing out the window. So that's where, and we're going to talk in the next segment or two about hybrid search and about how you really leverage your deterministic database-driven information and this new generative stuff that's coming from the LLMs. But don't touch that dial, folks. We'll be right back. You're listening to DM Radio. All right, folks, back here on DM Radio. We're talking to Daniel Bukowski of Data Squared. And you challenged me this morning to figure out how to do squared on on the Mac keyboard. I'm like, all right, how do I do this again? And the instructions I got were wrong. I'm like, okay, well, there you go. So I just copied it from your LinkedIn page and pasted it, and matched formatting.
I was going to
Just
say the best answer that I still use is copy paste.
Yeah, there you go.
That's
That's what I
right.
did. I just copy, paste. And speaking of, in LLMs for coding, this is a big deal for coders. There's this whole copy paste movement going on now, and I know some purists out there. My buddy Mark Madsen, I just saw him at TDWI in Vegas, and he was like, "No, no, 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 no bueno. Don't be using all the copy paste stuff." The theory is that although it may solve a short-term problem, you're kind of opening the door to longer maintenance issues down the road, and that very well may be the case. I mean, your tech stack is heavy duty stuff, and it needs to be correct. And one thing I'm learning is that, these engines are great for prototyping, but you do want to fine tune whatever the output is. You want to take a hard look at it, make sure it's correct, because little mistakes can cause big problems, especially in computing. It does not compute, right? But we do have a great question from one of our virtual studio audience members. And folks, if you want to be a virtual studio audience member of DM Radio, go to dmradio.biz and register for one of these shows. We use Zoom to record, so you can actually attend as a virtual studio audience member. And the attendee is asking what kinds of real business problems are most suited for systems, answers being at least 20% of the time wrong. And the answer is anything creative, obviously. I mean, for creativity, for copywriting, for press releases, for quotes. If you're a writer, they're really good at just kind of teasing your own creative juices. Like I'll use it to come up with a list of cliches. Give me 20 cliches that deal with money. And you go through it like, oh yeah, that's one. That one's on the money, for example. Like, yes, that's the one I want. So it's good for that stuff. It's good for anything as long as there's a human in the loop. So it is great for coding. I mean, you can write Python scripts, you can write all kind of stuff because it's all out there. And again, it's not that these systems capture and persist the exact data elements. They don't. They're just looking for patterns. And if you get right down to it, machine to machine conversations are probably a lot less complicated than human to human conversations. We have many more words than you have functions in most programming languages. So natural language is pretty darn complicated if you get right down to it, especially with synonyms and antonyms and all these things that kind of throw us curveballs left and right. But David Sweenor, I'll throw it over to you. What do you recommend? And of course, you've got TinyTechGuides on LLMs. What do you recommend people use these things for?
I use them for everything. Tell you that, but where can you be wrong most of the time? I think you hit the mark there, Eric, with some of the things where there's a human in the loop. I was at a trade show once. This was a while ago, and a gentleman from the NSA was recruiting there, and I'll never forget this. He said, "We have the world's brightest minds going to work for companies to learn how to send a coupon." And because there's a much higher pay than the NSA did. NSA is probably much more interesting work. And so sending coupons, you could probably be wrong. That's okay. Nothing's going to happen. But if you're in finance, I'm not going to run my financial books with an LLM. I'm not going to run my supply chain with an LLM. Maybe I'll let it transcribe some doctor's notes, but even transcriptions have errors.
Right.
There was just an article the other day. It
Right.
was making up stuff in just the transcription piece of
Oh
it. I'm
no.
like, oh my gosh. But you have to have that human in the loop. You need the oversight and to make sure it's not doing anything, nefarious.
Yeah, that's right. And I'll throw it over to Daniel. Of course, with the graph rag solutions you deploy, you could do all kind of stuff. What's one of the more gritty examples where you've had great success using graph rag and large language models, Daniel?
Absolutely. I think to the original point, like what would you use a out of the box LLM for? The best analogy I still go back to is they're a very talented high school senior. Like
Right.
what would be something you would give a second year college student or a high school intern as a task, acknowledging they're not going to be able to do everything and there's still going to need to be oversight, like you said. Like that's kind of the mental model I used. I think is pretty effective. But for the use cases we are working on, again, it is those where you have that high reliability. So, our founders have a lot of experience in oil and gas and energy, and we're looking around saltwater disposal, which is kind of a niche topic I'm not an expert on, but it is how can you make land-based wells more effective and more efficient and more safe to work on? That's something where you wouldn't give it to a high school intern or a college
Right.
intern to manage. You
Right.
need multiple levels of validity and guardrails and constraints on those answers. We're working on some government POCs around cybersecurity, and so how can you identify and detect threats in data that, from several very large pipes of data coming into the graph to know where does an analyst need to put their attention around an attack
Right.
or a threat or something that's emerging. Again, national security, these types of use cases need that high reliability because we are bringing our best analysts and putting them on these tasks. And so that's where
Right.
it's not just the LLM, but as we move forward, function calling and tool calling. So you have a vulnerability, in an IT system. It's one thing to detect it and write a bulletin, but what about how you respond to it? How about, okay, I can I can see through the graph, I have these sets of tools. I'm going to select this one and apply it to apply a patch to this server or so for an example. So it's not just understanding and reporting it as we move forward. What are the actions that are going to be taken or allowed to be automated because you need that immediate response? And how do you get enough accuracy when the LLMs are doing things, not just returning text or other types of data?
Right. That's
Mm.
so interesting. And I'll throw it back over to you, Daniel, and then David. We'll pick you up for the podcast bonus segment. But I think to myself, these are pattern recognition engines. And of course, they've been trained on text, all kinds of text. They've been trained on images. One of my other clients is one of the coolest companies I've come across, Hammerspace. They're actually being used to orchestrate the data to feed Meta's large language models, Llama 2 and Llama 3. So they're out there on the front lines actually feeding these things, right? And it's absolutely fascinating. But what I'm hearing from folks is that they can figure out all kinds of stuff, things you never thought they could know. There's some particular programming language I'm told that ChatGPT was not trained on, but it's still able to replicate and reflect. And you're just like, oh, that's pretty cool. So for stochastic purposes, for just exploration of ideas, they're also very, very powerful, right? Go ahead, Daniel.
Oh, absolutely. I mean, just, like David said, I use language models all the time. I use them to help, plan and do research or, kind of, like you mentioned, come up with ideas for, the things that I'm working on, or even come up with data for a demo that I'm working on. I have an idea, help me flush it out and kind of fill in the details. I need to come up with some synthetic data to demonstrate, how we can use a graph and AI. I use them for all of these different types of tasks, but I'm still in the loop. We are all still in the loop, making sure this is what I want, this is what we're going for. And I think this really ties back to the importance of, software development skills and good, high quality data engineering, data science, because if you've used some of the programming tools or Cursor, which I love and use, if you just let it do its thing unchecked, it will over-engineer, it will go off in a
Right.
direction you don't really need to.
Right. That's what
And
I've heard. Yes.
oh, it absolutely does. I was building a tool to generate synthetic data, and I wanted to say, okay, I want to see how far can I let Cursor go with this. And I'm not a software engineer by any stretch. I'm at best a vibes coder, but it was really taking it off the rails, and I realized, okay, I need to, there's too much going on here. It's become too complicated and borderline unusable. And so that's
Right.
where
Mhm.
you still need those high quality engineering and development skills and especially data engineering, especially software engineering, especially application architecture. And that's what we're trying to provide to our customers. You don't have to build this from scratch. It's very difficult, especially when you're using graphs. We're getting you 80 to 90% there, and you just need to do the final integration. So we're doing all the hard work with our team so that you can have a 90% solution to deploy on your most high value, high challenge problems.
That's right. And you know what? In terms of lessons learned, Daniel just made an excellent point there that I've heard now from multiple people, which is you have to be careful about what you let these things do and do not rely upon them as a foundational component of your architecture. You can use it for all sorts of ideation and prototyping, but when you go into production, don't put them in some place where they're going to be actually generating code in real time because they will overcomplicate things. And they're even changing ports. He was telling me, it's like, dude, I told you only use these ports, and now you're using all these other ports, and so it just becomes unmanageable, and it's a nightmare. It's like letting the interns just rewrite your finance system or something. It's not a good idea, man. They're going to bring that thing crashing down. You're going to be a very, very unhappy camper. We got one quick segment left, folks. Don't touch it down. We'll be right back. You're listening to DM Radio. All right, folks, back here on DM Radio with David Sweenor of TinyTechGuides and Daniel Bukowski of Data Squared, a very cool company I've just come across thanks to Neo4j and my old buddy Philip Rathley, who I interviewed on DM Radio like 17 years ago. I think when he was at Embarcadero or something. It was a long, long time ago that I interviewed this guy on this very show. So we've been doing this a long time. But the David Swinner, I'll bring you in. First of all, Praxi Data is the other company that's really good for working with unstructured data. They use ontologies to kind of help you go through, and dark data is one of the terms that they use to go through and clean that stuff up. And then I mentioned Hammerspace, which I view as a really interesting play. Now they're largely being used by bigger companies. I mean, they're being used by Blue Origin, They're being used by Meta. You got some pretty big clients, and it's unstructured data orchestration. It's a parallel file system, but you can get a handle on all of your files wherever they are, because file systems turn out to be pretty darn important. And he made a really interesting comment on a show a couple months ago where he said, if we had this hyperscale NAS, network attached storage, years ago in something like Hammerspace, we wouldn't have needed to dumb everything down for the cloud. All that refactoring that was done for the cloud, it's like, well, we did that because most applications expect a file system. That's what they're built for, right? So it's like, it's so fun learning about this stuff. But I'll throw it over to you in terms of things not to do. Like you said, be careful, man. Like having it do, it'll change settings, it'll change whatever it wants, just like for what, who knows? It's not sentient. That's the thing. People think, oh, is it sentient? No, it's not sentient. Okay. It's just a pattern recognition engine that's changing things. But final thoughts from you, David, on lessons learned and recommendations for using large language models.
I think you have to be careful is my message. And, Daniel mentioned that, we can, these things can generate citations. Probably the best one on the consumer side is probably Notebook LM. It does not make up stuff.
Hmm.
If you, by Google, if you do the same sort of types of activities in any of the other services, you say, don't make up stuff, it makes up stuff. And then they're getting better at citing things. But if you go look at the things they're citing, you go read it. It's some AI written piece of crap. and so you have to use your eyeballs. I tell people you have to actually go read it and make sure it's a reputable source. Just because it's citing something doesn't mean it's a valuable source. And I don't know, Daniel, if you have any thoughts on that, but how do you even know it's citing the right thing? It's a good citation versus a bad citation.
No, absolutely. If you use like a Perplexity or Google or kind of any of the deep,
Perplexity is the worst.
you have to be really careful with what they're citing. And I'm glad you mentioned Notebook LM. I've been using it since it was first launched.
Yeah.
And again, it's as a consumer-facing tool where it just vectorizes your data, and it is very strict about how it only uses the provided PDFs or text or whatever. But for any of the other deep, I think OpenAI has deep research. You have to be really careful with what it's referencing and what it's citing to make sure it's actually high quality information. That's where it goes back to retrieval augmented generation and GraphRag of providing the LLM with the data you want it to use and making sure that it is only using that data. That's what enterprises are going to need for these production applications, because their internal data is not part of the larger training corpus, or at least it shouldn't be, so
Right.
you have to make sure it's given the right information and focuses on that.
Yeah, in terms of other lessons learned too, what I've learned working with these things is like again, they're so powerful and you're like, wow, how did it do that? But when especially with the images, if you try to fine tune something, it's not good at that. So you say, I want an image that looks like this. And like, boom, wow, that looks close. Well, that's when you hand it off to an actual designer to go into a real design program to design your logo. Like you don't
Mhm.
want, because they don't fine tune very well. And the other thing I heard for bolt.new, and this is a real fun story to close with. My good buddy who's a developer, his girlfriend is not a developer, but she's working with a company that needed a new website. And they had a group of offshore guys far away that spent 6 weeks building something that was kind of okay, but it didn't really work. She used bolt.new to create it in 2 days, and it worked fine. And you're just like, holy Christmas, that's kind of a big deal. A person in 2 days can bang out a successful iteration of what it took a whole team of developers 6 weeks to kind of not do so well. I mean, that's a real straw in the wind here
Mhm.
to recognize something's happening. But he told me one really critical thing. He said, do not use fake data when you're trying to build one of these apps with like bolt.new, for example, because even after they said, okay, now we want to use the real data, it kept throwing the fake data back at them. So there's something about these things in certain context windows, I guess, where they're like a dog with a bone on something and they just won't let it go. And you got to start over again. So again, it's good for prototyping. It's good for getting almost all the way there. And then you got to take it offline and go fine tune and finish it out yourself. Final thoughts from you, Daniel.
Absolutely. I think that really is the top use case is, would you send an intern to go help start some research or write the first draft of a report or write the first draft of something? Then you take it and do the final touches, the finishing touches to make sure the intent and the accuracy is what you want. And that's where, that's using an LLM out of the box for a kind of a permissible use case. But when you need to get to that high level of accuracy, that mission critical implementation, it's a lot more work and a lot more guardrails. And that's where, we really think graphs are going to play a key role in that. That's why we're building on a Neo4j graph database so that you have the accurate citations back to your data,
Right.
or when a 10 to 20% accuracy or inaccuracy rate is simply not acceptable.
Yeah, and that's like most use cases. And then
Yeah,
David
it's
Sweenor.
most use cases you wouldn't give to a second
No,
college intern.
no, no, unless you want to lose your job or lose your customers, in which case, oh, well, maybe self-sabotage.
Then I'll sell our platform to whoever replaces you.
There you go. That's an opportunist right there. And David Sweenor, final thoughts from you. What's the name of your book you wrote with Eve Melker? It's all about large language
So,
models.
so yeah, these things are real. They're out there. So we have a Tiny Tech Guide, generative AI business applications. So there are 70 real world use cases. They are all cited. They were from press releases and things like that. So it's not when these things first came out, it was the art of the possible. They could do this. These are documented use cases. I have a more technical one for practitioners and for any marketers out there. We have the PMM's prompt playbook. These are 30 prompt workflows, like 12-step workflows that an individual can use to get their job done. So check them out, tinytechguides.com.
I love it. What a fantastic show today. Thanks to our virtual live studio audience for your great questions today. And thanks to our guest, Daniel Bukowski of Data Squared and David Sweenor of Tiny Tech Guides. And you'll see Data Squared on a webinar in early April all about graph RAG. So send me an email if you want to be on the show, info@dmradio.biz. That goes directly to yours truly. And with that, we will bid you farewell. Thanks again. You've been listening to DM Radio.